Hello class, welcome to Unit 7.3, Multiplying Polynomials. Today we're going to take a look at how to multiply polynomials. Now in general, what this is just distributing all of our terms. You will also be hearing a lot of teachers and people say FOIL, which is really just an acronym for your first, outer, inner, and last. So what that's going to allow us to do is just kind of help remember how to do this multiplication. So the way that looks, and we zoom in here, if you're just going to use what's called the FOIL method, what we're going to be looking at first would be we're distributing those first terms. So that would technically be your first. The outer would be your outer terms. And then you'd have your inner terms, and then the last terms. And that's where we're going to get FOIL from. And you can see that the first term we're distributing 2x times 3x, 2x times negative 7, the 4 times 3, and then the 4 times negative 7. So as we do this FOIL method, we want to make sure we actually multiply. So 2x times 3x is going to be 6x squared. 2x times negative 7, well, 2 times 7 is negative 14x. Your inner terms would be 4 times 3, which is going to be a plus 12x. And your last terms are going to be 4 times negative 7, which makes that negative 28. Now, as you can see, we still have some like terms like we've been practicing. And we want to make sure that we combine them. So negative 14 plus 12 would leave us with a negative 2x minus 28. And there we just multiplied those two polynomials. Also want to take an opportunity, there is going to be a thing called the box method, which is just going to be an alternate way of doing the FOIL method. Now, those of you guys that are familiar with lattice, what we're going to end up doing is setting up these nice little box for, 2 by 2, which is going to end up being like 2x plus 4. And then you have your 3x minus 7. And it's going to work a lot like lattice, where we're just going to say, well, what's 2x times 3x? 6x squared. What's negative 2 times 7x? What's 3x times 4? And what's 4 times negative 7? And again, when we kind of work down through our diagonals, you would have 6x squared. We got some like terms down this way, so that's where the negative 2x, and then we have the negative 28. So either way are both pretty nice methods of solving. It's really just going to be a matter of which one you like the most. So a lot of what I would recommend at this point is going to be box method. And I'll show you why here in these next examples. So when we look at some more examples here, and really it's going to end up being a case-by-case basis, because this one here, example 2, looks pretty easy. We only got one term out there. It's still multiplying, but we're just distributing. Now, the big thing we want to remember here is also as you multiply x squared times x to the third, you're always adding exponents. Okay, this is different than combining like terms. When you're trying to multiply, we add those exponents. So then x squared plus 4 would just be plus 4x. Now, if you want to choose to kind of get good at this box method, well, that means there's x squared on this side. And you'd set your box up with x to the third plus 4. And then we'd say, well, x squared times x, and it's still just going to be this, add those exponents. And x squared plus 4 is still going to be 4x squared. Well, there's your answer. Just another way of organizing so that we make sure we distribute to all of our terms. And where I really like the box method is for problem number 3. Okay. The reason being is if we are going to try to distribute these, you would have to distribute this times this, and that FOIL no longer. X times 2x and x times negative 5. We would also have to take the negative 7 times x squared times 2x and times negative 5. Now that could get really messy as we start listing them out. The reason I like the box method here is if we just, kind of think about what we're doing, we have that x minus 7 on the side. And now this one, we have 3 terms, so we're going to make sure we have room for multiplying 3 terms. So if you have the x squared plus 2x minus 5, and it's still going to be the same thing as we distribute, but it's going to be x times x squared, x times 2x, negative 5 times x, negative 7 times x squared, negative 7 plus 2x, negative 7 times negative 5. And now what we have is our answer, and it's pretty much already set up along our diagonal. So first one would be x cubed. Negative 7 plus 2 is negative 5x squared. Negative 5 minus 14. And then lastly, plus 35. So it really doesn't matter if we want to distribute all of them. Now, if you are going to try to use the distributive method as you try to FOIL, but with more terms than that, it doesn't work as well. You're still going to end up with the same thing where we get like an x cubed. Do that next one where it becomes plus 2x squared. Do that third one where it becomes minus 5x. Now, here's where you got to keep going with this, and this is where if you're going to stick with this method, I would kind of say, okay, negative 7 times x squared. Well, that's going to kind of match up there. Negative 7 plus 2x. That's going to match up with our negative 14x being matched up with negative 5x. And then negative 7 times negative 5 becomes plus 35. So as you kind of list all these out, it just doesn't have the nice box method that we're used to. But again, as you kind of add these down, you can see that that first one here becomes your x cubed. The 2 times negative 7 becomes your negative 5. Negative 5 and negative 14 become your negative 19. And then your plus 35. So either method you work with, we just got to pick one and be good at it. Like I said, especially if you're used to lattice, I would be working these next couple practice problems using the box method. All right, so let's take a look at them and have you guys practice them and see how that goes. So make sure you pause here and solve through these next couple problems. Okay, take a few minutes here to pause and just check your work. You can see I used the box method to organize my work, but we should end up with the same terms no matter whether you FOILed or did this box method. If you FOILed, you'll see these those numbers instead, just all on a list before you add them. The big one I want you to kind of focus on is number 7. Notice here, we've been kind of adding across this diagonal, but look what happens when we have an x squared, 6x, and these aren't the same, the same variables up here, the same degree. When we get across them, they are not the same, so we cannot add them together. In all of the other cases, if they're kind of lined up correctly, they typically do add across any of these diagonals, but you do need to kind of just watch out for them. Other than that, let's keep going. Okay, so for example 2, now that we know a little bit more about multiplying, some of the applications, of course, kind of come into area. Because how do we find area? That's going to be length times width. So if we're looking at area as length times width, what we're looking at here is x squared minus 3 times 7x plus 6. So again, whether we go box method or, FOIL method, we can work with that. Let's just take a look at the box method since that's what we've been kind of practicing. So if we start over here with x squared minus 3, 7x, and 6, When we multiply these out, we'll end up with 7x cubed, 6x squared, negative 21x, negative 18. Now again, we just got to be careful as we start adding up like terms, because these terms didn't match up. When we look at this x squared and we look across that diagonal, they are not like terms anymore. So we need to kind of just be aware that as we, write out our final answer, we'll have 6x squared minus 21x minus 18, since they are not like terms. Okay, so there's that. You also got example B over here. So let's just kind of shift and talk about area equals length times width. So again, we got 2 terms for this one, 3 terms here. So when we create our box, we need to extend it a little bit more, because now we know that this needs to be broken up into 3 sections. So let's go with 3x minus 10, 14x squared minus 7x plus 5. And then we can multiply through. So that'd be 42x cubed. We'd have a negative 21x squared plus 15x minus 140x squared minus plus, actually, negative times a negative. And then we would have negative 50. So, at this case, we are just kind of be aware as we try to add these up that our variables do line up, which in this case, they look pretty good. 70 plus 15 is 85 minus 50. So, nice long polynomial answer. But again, we're just taking that time to just multiply, use that box method, and solve. When we look at example 2 and we're trying to find the area of this shaded region, this is kind of like a rectangle, within a rectangle. So what we really have going on is we have this bigger rectangle. We'll call that basically everything in there, the area of 1. And what we're really going to need to do is subtract out this area 2 that we're going to find by this little smaller rectangle inside. So again, how do we find area? Area is just going to be length times width. So the first thing we need to look at is, what is 9x? If we're going to try to find the area 1, what is 9x times 16x plus 5? So if we look at that, we'll have x squared and 45x. So we have that first area coming in at 144x squared plus 45x. When we look at the area of rectangle 2, that's just going to be our 4x times 7x minus 2. So we got, 28x squared minus 8x. And because this is a shaded area within, basically what we're trying to do, let's see if I can show you with these pictures here, is if this whole area is blue, what we are trying to do is subtract out the red. That way we are essentially back to just the blue shaded area. So our next step is simply going to be the area 1 minus area 2, which at this point we just need to kind of use our subtraction to solve. So that's a 45 plus 4x, and that is going to subtract out this 28x squared minus 8x. So here we are at the point where we are going to distribute. And since these are going to stack up pretty nicely, we'll say minus 28x squared minus minus is plus 8x. And now we're subtracting. So what do we come up with? 116x squared plus 53x would be the area of that shaded region. Okay, pause here and try that example B following these same steps. Okay, take a few minutes to kind of just work through that again. Just trying to multiply that bigger rectangle minus that smaller rectangle. And we should hopefully come up with 66x cubed plus 40x squared plus 24x. Okay, so let's look at some word problems, which read through here. Samantha is building a rectangular patio in her backyard. The patio will have a length of 3x squared plus 4x minus 7 yards with a width of 2x squared minus 6x plus 1 yards. So let's kind of take a look at this. We're drawing a rectangle. We have one of them, the length being 3x squared plus 4x minus 7. We have the other width being 2x squared minus 6x plus 1. That just helps us get a little visual of what's going on. Question 1 is asking for area. Well, what do we say area? Length times width. This looks like a good problem to set up our box method multiplication. So as we take a minute to set that up and multiply, we have something that looks like that. All right, so finish that up. All right, and in the end, it looks like we should come up with a 6x to the fourth minus 35x squared. That should be, because 8 minus 8 should be a 0. And we have 46x minus 7. Second question, part of this is what is the perimeter? Well, perimeter, if we're going to try to add this up, maybe we want to fill in these missing sides just to make this a little bit easier. So it looks like if we are going for perimeter of the patio, that means add them all up. So what are all our x squared? Well, that's 3 plus 2 plus 2 plus 3, which looks like that'll be 10x squared. If we go to the x's, negative 6 plus 4, negative 6 plus 4. So it looks like we'll have, what is that, negative 12 plus 8 minus 4x. And then lastly, we have all of our constants to go. So negative 7, that'll be negative 7 is negative 14, plus 1, plus 2, negative 12. All right, try out the rest. Let's see what this next one is. If Samantha puts in an x squared plus 3 by 2x minus 1 fire pit in the middle of the patio, what will the area of the patio be? All right, this looks like this is going to be one of our rectangles within a rectangle. So we found that bigger rectangle, but now we're looking at trying to put another one in. So first thing it looks like we'll want to bring over from that last one is our area of the bigger rectangle. And now it looks like we need to figure out what is this area of the smaller one. So let's take a minute to set up our box method and solve. Okay, so take a second there. Be careful. That is an x squared and is 6x, so we cannot combine them. And now that we figured out what the area of this smaller rectangle is, remember, we are subtracting that from the larger one. So in this process, let's kind of come up here and subtract. Well, there is no 2x cubed up there, so be careful. We are going to be able to add an x squared. We'll be able to subtract the 6x. And we'll be able to add that 3. So, final answer, 6x to the 4th minus 2x cubed minus 34x squared plus 40x minus 4. Okay, a lot of work there, but just remember, every time we see these, solve these, all we're using is some basic ideas. Just polynomials make it seem a little more intimidating, but really, they're not that bad. So, have a nice day, finish up your work, and see you tomorrow. Goodbye.